We've got a word problem here. Let's just read through it and get an idea of what's happening. It says the number of visitors to public libraries increased from 1.5 billion back in 94. So back in 94, about 1.5 billion people went to the libraries. In 98, 1.7 billion people went. Find the average rate of change of the number of library visitors. Okay, now here's what we know. The average rate of change, right? The average rate of change, this is equal to the slope. So as long as we know that, when we see this here, find the average rate of change, I'm just going to use the slope formula. And the slope formula we know is m equals, all right, second y minus first y over second x minus the first x. Now I'm going to write some ordered pairs here. Here's what I know. In 1994, 1.5 billion people went to the library. So here's a point. In 1994, 1.5 billion people went to the libraries. Then, in 98, 1.7 people went to the libraries. So in 1998, 1.7 people went to the libraries. Now, be careful here. The numbers go backwards, right? It says 1.5 billion to 94. But it was in the year 94 we got this many people. All right, so I'm going to put this number first. Now, this is x1. This is y1, x2, y2. Let's substitute. So we will get that the slope, the average rate of change, is, all right, what do we have on the top? Second y minus first y. So second y is 1.7 minus the first y, 1.5. 1.7 minus 1.5. And in the denominator, the difference of the x's. The second x, 1998, minus the first x, 1994. So 1998 minus 1994. This will give us, the slope is, now 1.7 minus 1.5, that's a 0.2, all right, 0.2. And 98 to 94, that's just 4 years. Now, if you do this on your calculator, or you can just do this, move the decimal 1 over here and 1 over here, and that's the same as, what, 2 over, come on now, that's the same as 2, I don't know, I'm having trouble with this one, 2 over 40, which gives us 1 over 20. All right, so the slope here is 1 over 20, or 0.05 if you did it on your calculator. Now, if I write this like this, 0.05 over 1, that means bottom number, top number. The bottom number is the change in the input, right? Look at the bottom over here in the formula. The difference in the input, right? X's are the inputs. So this is the change in the input. This is the change in the output. Now for us, the input is the number of years. So if I increase the number of years by 1, so I'll write that here. So if the number of years increases, I'll abbreviate, increases by 1, the number of people visiting libraries, you can almost read this, increases. Now I'm saying increases because this number is positive, this number is positive. Increases by how much? 0.05, but it's in billions, by 0.05 billion. Right, so every year we're getting 1/20th of a billion people coming to the libraries. So the point is, I mean, here's the answer. It's nice to get a number, but it's even nicer if you know what it means. So I always write the slope over 1 if I'm trying to get a physical interpretation. So the bottom number tells me if I increase the input, whatever it is, by 1, the output is going to increase or decrease by that amount right there. Decrease if it's negative. Now in 14, we know this. The number of crimes that occurred in some city per 1,000 people had decreased from 45.7 per 1,000 people in 1920 to 43.6 in 1990. All right, so in 1920, there was 45.7 crimes per 1,000 people. Then, if you go up to 1990, the number of crimes is down to 43.6. Can we find the average rate of change? Okay, from 1920 to 1990. Well, there's the key, the average rate of change. And we know this, that the average rate of change, that's equal to the slope, and that's our m. So here's the slope formula. M is equal to the second y, the second output, minus the first output, over the second input minus the first input. So let's identify. I'm going to draw some ordered pairs here. So in 1920, the number of crimes was 45.7 per 1,000 people. Now, then, in 1990, number of crimes was 43.6. Now, here is the first x, the first y, the second x, the second y. Let's substitute those values into our formula over here. So the slope will be, or the average rate of change will be, now the difference in the y's, okay, that's the second values, 43.6 minus 45.7. 43.6 minus 45.7 over the change in the x's. Second x, 1990, minus the first x, 1920. Now, if you're not sure how to do the top, just get your calculator. I am getting negative 2.1 over, now 1990 minus 1920 is 70. Now, if you want, I think the book is going to want us to put in the division. So I'm going to divide that by 70, and I'm going to get that the slope here is equal to negative 0, too many zeros here, negative 0.03. All right, so I'm going to say that the average rate of change is negative 0.03. Now, the 0 means it's decreasing. So if I got a number for it, now if I want to know what it means, I would write it like this. All right, and here's what it means. Here's how I would interpret that. So here's how I would interpret this. The bottom number is the number of years, and it's positive. So if the number of years increases, because it's positive, so if the number of years increases by 1, then the number of crimes, that's the top number, per 1,000 people, decreases by 0.03, right? Decreases by 0.03.